Hello friends, you're welcome. In this video, we're going to be finding the value of x, and the equation before us is 6 raised to the power x plus 1 is equal to 3 raised to the power of x plus 2. Now, for us to solve this question, I will have to take the logarithm of both sides. So I can drop the exponent and just multiply the logarithm by the exponent. It's a way of dropping the exponent that I have on both sides of the equation. So I'm going to take the logarithm of both sides. As I said earlier, it's going to be log 6 raised to the power x plus 1, and this is equal to log 3 raised to the power x plus 2. So like I said earlier, from one of the laws of logarithm, when you have a case like this, you can drop the exponent. You can use the exponent to multiply the logarithm. For instance, you have log a raised to the power x. This can be expressed as x times log a. So that's exactly what I'm going to be doing on both sides of the equation. So it's going to be x plus 1. I can wrap this in a bracket, log 6, and this is equal to, here, do the same thing, x plus 2, wrapped in a bracket, log 3. So the next thing I want to do is to multiply these 2 and these 2 as well. So let's do that. X times log 6 is x log 6. Then 1 times log 6 is plus log 6. This is equal to x times log 3 is x log 3. And 2 times log 3 is 2 log 3. So what I want to do next is to collect like terms. The terms that have x in them, I'll put them on one side, and the ones that don't have x in them, I'll put them on the other side. So let's transpose x log 3 to the left hand side. I'm going to have this x log 6. Then if you move it over to the left hand side, this, you have to change the sign. So it's going to be minus x log 3. And do the same thing here. This will be 2 log 3. Then transpose log 6 to the right hand side, you have minus log 6. So if you check what we have on the left hand side, x is common. I'm going to factor that out since I'm even trying to find the value of x. So let's factor x out. I'm going to have x, open a bracket. X will go into this, you have log 6, put in a bracket like so. Then x goes into x log 3, you are going to have log 3. And this is equal to, I told you about one of the laws of logarithm that we used when I moved the exponent to multiply the logarithm. I'm going to do the reverse of that here. And I'll move this 2 on top of here. So it's going to be log 3 raised to the power 2, then minus log 6. So what's the next thing I'll do? Let me just keep doing this. So x, I can apply one of the laws of logarithm. If you have log a over b, this can be expressed as log a minus log b. So because of this division, you change it to minus, but you now have to have a logarithm of this a as one of the argument, then the other logarithm will have b as the argument, as the number or the value that is with the logarithm. So that's what I'll be doing here now. I'm going to be moving it from this form as I have here, log 6 minus log 3. It becomes log 6 divided by 3. You can transform it to this again. So I'm just doing like the opposite of what I just did. You can wrap this in a bracket. This should be equal to 3 raised to the power 2 is 9. So that would be log 9 minus log 6. So here, 6 divided by 3 is 2. So it's going to be x log 2 is equal to log 9 minus log 6. I'm going to apply that law of logarithm that has to do with subtraction. That's the division law of logarithm. So it's going to be log 9 divided by 6, like I explained earlier. Okay, so that's x log 2 is equal to 9 divided by 6. Okay, let's just simplify this. 3 here is 3. 3 here is 2. So you have log 3 over 2. Now, before I divide both sides by log 2, I want to write this to this form. Division law again. I'll just make it minus and put 2 logarithm. So it's going to be, let me just write it here. X log 2 is equal to log 3 minus log 2. You see what I'm doing? Now the next thing I'll do obviously is to divide both sides by log 2. Let's do that. So x is equal to log 3 minus log 2, all divided by what? Log 2. But you know that I can split this. I can make this divide this, and this also divide this. Of course, we can do that. So I'm going to write x is equal to log 3 over log 2 minus log 2 over log 2. Now, actually, you can skip this and just move straight to this, because when I say divide both sides by log 2, you can actually say divide every single term by log 2, and you won't have to write this one at all, but it's still fine. Obviously, look at log 2 and log 2, it cancels out. Then you have x is equal to log 3 over log 2 minus 1. Now, I don't know that you know change of base in logarithm. This is okay to be the answer, but I just want to make it a little more simplified using change of base in logarithm. If you have, say, log a over log b, and you want to change the base here, you can change it to become log a base b. So this, the default base here is 10 actually, but I just changed it to base b. So using change of base, I'm going to have x is equal to log 3, then base 2, then minus 1. I just use change of base to express it in this form. Okay, I hope you got value from this video. If you did, kindly like and share this video and follow for more. Thank you.